Jessica, welcome to our Software Craftspeople India community. This community is a not-for-profit organization. Our goal is to connect people with software craftsmanship mindset. We organize talks, roundtables, and workshops to help the community get better at our craft. We also have Slack and WhatsApp groups where you can get updates and reminders on the latest events. We'll share the links with you by end of the talk. If you want to join the group, please click on the link and join the groups. Incubite is the founder and sponsor of this Software Craftspeople India community. We are focused on delivering well-crafted software solutions for our customers. Quick introduction of Jessica. Jessica currently manages developer relations at honeycomb.io. She's the OG of observability, and she's also a thematicist in the medium of code and helps team grow more useful software. She's a speaker and panelist on podcast Greater Than Code and Arrested DevOps. She runs these fabulous workshops on systems thinking, which I was lucky enough to join, and I got to know her over there. So thanks a lot, Jessica. Let's get started. The stage is all yours.
Okay, let me share my screen. All right. Screen. All right, let's see. Thank y'all. Do y'all see yourselves?
Yes.
Okay, there. Slides?
Yes.
Great. Thank you, Sapan, and thank you for inviting me. I'm happy to speak to a group of people who care about writing software. When we think about writing software, and a lot of the talk in software craftsmanship is about coding, which is reasonable. Coding is hard, and the way we do it matters. And in this presentation, I want to talk about more than the coding. I mean, of course, everything starts in code, but that's not where it ends. That's not the end goal of what we're doing. So we can get really good at even more than coding, at the iteration of software development, of testing and code review, and then demoing and learning something different and tweaking that, and writing tests first, and all of this craft that is part of while the software is still like private to our team. But that's still not where the software gets useful. So there's a big difference between coding and getting something done. And by something done, I mean like change in the world that is affected by our software, so that our customers' lives are different. And that could be, in the end, it's like the customers of our company, but often our customers are software, external or internal, but still the world of possibilities, either in apps or in software, is bigger because of what we did. And there's a lot of stuff that comes after we release the software, or after we let it out of our development cycle, that comes into that. Of course, today I'm going to talk about my favorite bit, observability, because I think that is an essential piece that can have a lot of value both to our development cycle and to the way we get something done in the world. And it's emerging as a standard, and I'll tell you why in a bit. So after our software leaves our care, there's a lot to do about it. And this is hard because as a dev, to begin with, production is scary, right? I don't know how it works. I don't know how the infrastructure works. I know how my little piece of the code works, but I don't usually know all of the ways that my code is triggered, or what happens to the data after I return it. And a goal of observability and of this talk is to change from production is scary to production is my friend. Because if we really want to make change in the world, we have to actually look at what's going on in the world. And that's where we have to do that in production. And that's where gaining the powers of observability can feed back into our development cycle and make us better software craftspeople. So my goal as a developer is not to write code, it is to support valued capabilities. By changing software, I make things possible in the world that weren't before. And I want to support code that is increasingly reliable. People need to be able to count on those capabilities being there. And I need to make it more valuable. More people need to use it, so we need bigger scale. And then, of course, we want our capabilities to do even more. We want our software to have more features. So as an example of capabilities that make the world different, 15 years ago, if I wanted a ride, I had to like call somebody, but now I can pick up my phone and move some buttons and a car shows up and it takes me where I want to go. And that is magic. That is so powerful and it changes the way my world is. But there's a whole chain of capabilities under that, from the app itself to the mapping and the driver matching, and many teams added capabilities that made my world different. Right, so we want, usually the listed goal for our team is to add more features, but those features aren't useful unless they're running in production and working together. And that means every feature that we add, it makes our software harder to maintain. That it's like they give you a list of requirements for the feature, but there's an invisible one on there that says, and everything else still works. So every feature adds complexity to our software. So in order to support valued capabilities, increasingly, I need to support more complexity. And supporting more complexity, we're going to need observability for that. Complexity in software, I mean, we talk a lot about keeping our software simple, keeping our code simple, and that's good. We need to do that, but it only goes so far. You want to remove unnecessary complexity. Sometimes that's adding abstraction. Sometimes that means removing it. But in the end, we want to support more business capabilities. We want to put the complexity of the world, all the details that it takes to like figure out who in my city might give me a ride right now and which one I should ask and how much I should pay them and how they should get from here to there. That is complexity. We want that in our software. So instead of trying to eliminate all complexity, the goal is to support more complexity, business complexity, and to work skillfully within it. All right. And now we get to the team, because our team is complex and we want to work skillfully within it. And when I talk about our team, I don't just mean the people, because if my goal as a developer is to support valued capabilities, I can't do that alone. I need the software running in production. The running software is part of my team. And that's tricky because with people, we can talk to each other. We know how to do that. We can ping each other on Teams, or we can tap each other on the shoulder and talk. But where there's a barrier between us and our software, between figuring out what's going on. And Dr. Woods and Dr. Cook from the resilience engineering community called this the line of representation, the barrier between the social and technical parts of our socio-technical system. And that line of representation is what we have to cross in order to learn anything or change anything in our software. So it is crossed in various points by things like our IDEs. We can see the code, we can change the code, and then our CI/CD systems, we add tests and the tests run, and then we get the output on a screen, and then we have a button maybe that says deploy to staging or deploy to production, or these buttons that we give ourselves and these screens and command lines and stuff. This is how we cross the line of representation. And that's limited. And when we give ourselves these clues, it's really powerful. So the software on the team is a learning system. We learn from our code if we watch what it does, we look at the data, we look at the test results at least, and our software learns from us because we change it. Right. And so we need to be able to see across this line of representation in order to do this work well. And in particular, we need to be able to answer our questions, like when something's wrong, what is failing? What is so slow? Production is scary when these questions are hard to answer, and production is on our team when our software is telling us via some sort of screen the answers. And also, you may think you know how your software works, but there's always something that has changed since you last looked at it, or some way people are using it that you didn't expect. So we also want it to tell us how it's working when things are good. You need to be able to compare the failure to what happens when it does work. And with these answers, we can do things like reduce downtime so that we have more reliable software, improve performance so that we can scale and go faster, and also onboard people. And not just people new to the team, but onboard ourselves to software that we haven't supported in the past, but we need to. And then we can support more capabilities because we can find out what's going on. To work skillfully in complexity, we need visibility into it. That means crossing the line of representation, and that means observability. All right, here's some definitions. Observability, the way I define it, is we can see inside our system because it tells us what's happening. And it tells us because we make it do that, right? It tells us because it sends us telemetry. And these words, observability and telemetry, they came out of rocketry and rocket science. Because when you shoot a missile into the sky, and then the news report says the missile went up to 500 miles per hour. Well, it doesn't know that because there's like a plane with a radar gun chasing it. We know that because the missile tells us it's measuring itself and reporting back to us how fast it's going. And that data is called telemetry. Telemetry data is not user data. It's not production data. It's just for us as developers and operators. That telemetry comes from code, of course. Everything goes back to code. It comes from instrumentation, which is code that just exists to send us telemetry so that we can know what's happening. We have this, of course. I mean, every log statement is sending a piece of data, a string, to us, hopefully, eventually, to try to tell us what's happening. But we can do better. I mean, logs are the simplest telemetry, but they are not the most useful telemetry, and modern standards have increased. So one other definition is that when we're talking about software, it's never just one rocket anymore. There's lots of components working together, and we need to add a piece to the way they talk to each other so that we can link our telemetry up later. It's an important piece of information. Which service called which service? That the app called the backend, and the backend said request ride. And then the request ride called who knows how many other components. So you've got to propagate the data of what we're doing and why, or who said it and why. And when you do that, you can take these log statements. Now we're in a little e-commerce app apparently, and we received a checkout request. And of course, you would print a log statement when you receive the request, and maybe you print a log statement about the database and a bunch of other things. But when we have propagation of some provenance data, we can link these requests together, or not requests. We can link this telemetry, these log statements, together in a causal structure. So we received a post, and that caused the work of checking out, which in turn caused us to call /cart, which caused us to do a select in the database, and so on. Now, if you also add a timestamp, yeah, say what service this is, definitely do that. And then add a timestamp and also a duration or a start and end timestamp. When did we do this and how long did it take? Then you can take these log statements and you can put them in like a waterfall view, it's called, where you put them all on a timeline of what was happening and what was happening at the same time, and how long everything took. And then you can highlight the errors. When there's an error one, you can like see where the error is, what service it's in, so you know what team to call, and also how it got there, which is significant. And then you can add attributes to these, and all of the little bits. Now at this point, each line here represents a single event that's transmitted as telemetry. And this event is now incorporating many log statements because you've got both the request attributes and the response attributes on the same event here. You've got that timestamp and that duration. So this means holding state in memory somewhere. It's not as simple as spitting out a string to a log and then forgetting about it. So these events are called spans in a distributed trace. So each row here is a span. It represents a unit of work. It replaces a bunch of log statements. And the beauty of it is through that propagation, they all tie together and we can draw a picture of the whole story of what happened in production for successes and for failures. We can tell the story. And this is the modern industry standard for telemetry. This is the best we have. It works really well on the back end. The front end is another topic. But for request response, this is a beautiful way to tell a story. And it answers the questions. We can see what happened. How does it work? We can locate errors quickly and know who to call and what code to look at. And we can see how long things took and therefore make them faster. Oh, I wanted to show you what a distributed trace looks like in real life. I would like to ask how many people have distributed tracing at work or have worked with distributed tracing? I don't know how to see the answer to that though. Maybe I'll see in the chat later. You can do. Yeah.
7 people says they have.
Great, excellent. Yeah, this is becoming common, but it's on the upswing. And it is the standard that I want us to hold as developers. We should like ask for this because this lets us see what's going on in production. You can so to see the distributed trace here, you can follow along at home. You can do this if you go to jessitron.com/OTel. OTel is for Open Telemetry, which I'm going to talk about in a minute. We have here the Open Telemetry demo app running on Kubernetes, and this is a fake e-commerce app that was built entirely to illustrate distributed tracing. So it's gratuitously complicated. It's got a bunch of microservices in it, but you can click on one of these fake products and you can add it to your fake cart. And then you can look at all these fake email addresses and stuff, and you can click place order. And it will not, in fact, send you a confirmation email, nor will it send you any products. But what you can do then is go to jessitron.com/otel/Jaeger, Jaeger. And Jaeger is an open source distributed tracing tool. And on the back end, it's storing all the telemetry emitted by the OTel demo app in memory, because this is a demo version of it. And then I can query them here. I can click find traces. It hates me. This does not always work because it's storing these traces in memory, and when it runs out of memory, then it just doesn't have them anymore. Well, here's something. Let's look at this. There's something that didn't work. Let's see if checkout service has anything. Checkout service, did you get any checkouts? Here's one. Let's try that. Aha. Okay. I think my front end tracing isn't working. That's fine. So in this is a distributed trace. This is the story of a post that came in. This one arrived at the front end service. This might actually be the load generator. That's fine. This one arrived at the front end service, which I'm sorry, the front end here is not the front end. It's the first back end service, and they named it front end, and I think that's terrible, but we deal with it. All right, so this tells the story of a request that came in at the front end service. It went to the checkout service, and that one called the cart service and the product catalog service and the currency service. So this trace is tying together the information from a bunch of different services, which is really nice when there's a problem and every team is looking at the same trace, and it becomes look at this together instead of my logs versus your logs. For whose fault is this? You can drill into any of these and get more information. Look at all these attributes. Ooh. Some of them are like normal status code service. Others of them are custom, like the currency, the order amount, the order ID, and the tracking ID. You can get really fine-grained with these. Subject to cost considerations, which I can talk about later if you ask about it. All right, so this is what a distributed trace looks like. I wanted to give you that picture. And you can play around with these because this is a public site. So I think I put it in the slides. PowerPoint, present again. Ta-da. Oh no, it went to the beginning. Arrgh. This is fine. Have some more capabilities. Instrumentation, and then we're going to build up the trace, and then we're going to see, aha, there's the URLs. Okay, so anyway, if you go to these URLs, you too can check out, and you too can go to Jaeger and play around and poke around in the trace and see what you can find. See what takes the longest. See if you can find any errors. And this is in case that demo didn't work, the picture of the trace and what's inside it. But the way that works, distributed tracing is not everywhere because logs are easier. So logs are what we've always had, and metrics too. Metrics are not as easy as logs, but they're easier than traces. And the thing is that we need that propagation, and we need a lot more for tracing to happen. So this picture represents like your software, and there's a couple services here, and they use some HTTP or gRPC libraries to talk to each other. One of them is talking to a database. What we need to get these distributed traces is instrumentation, the code that sends all of those spans, and we need that propagation. So every time we send a request over HTTP or gRPC, we have to say, what we actually say is the trace ID and the span ID. So you know the overall trace ID is the same for a whole request, and the span ID is different for each row, but we need to say which row caused this network request to happen. Right, so the way you get those is with libraries. I mean, you can code this yourself if you need to. If you wrote your own HTTP clients for your company, then by all means, you'll need to code this yourself to the W3C HTTP header standards. But in general, most of us use libraries for this to attach, and these libraries, like, they're per language and they're per HTTP framework and per database client, and they're really smart, and they hook in there and tell you a lot of what you want to know about what's happening in your system. And then that data has to go somewhere, and it has to be transmitted in some format, and that format needs to be standardized so that all the services are speaking the same language. Or converted, if you've got some that are already using older standards, you can do that. And somewhere that conversion has to take place. And we can go to the next slide, please. There it goes. Okay. So you need a pipeline. You need someplace to gather this data, sanitize it sometimes, check for PII kind of thing. And then that data all needs to wind up in a database. The database is known as the telemetry backend, which is a little weird because attached to the database is a front end, like you saw with Jaeger. Something has to like query and display the traces out of that, and that's also called backend, which is weird. But don't worry about that part. That part you can buy or operate yourself. What matters is all of this instrumentation and propagation, and like the programs that you need for the pipeline, this all has to run in your network. Now, historically, for what people now call observability, for monitoring and logging, people will, especially for metrics, people will run like the Datadog agent, or New Relic agents and stuff like that. And those like embed in your code. But this instrumentation does have to embed in your code, but you want that to be open source. You want all of this blue and green and purple stuff that runs in your network to be open source. And that's where OpenTelemetry comes in. And OpenTelemetry is the reason that distributed tracing is now the modern industry standard. Companies are big companies and small ones. Well, small ones are starting out in OpenTelemetry. Big ones are converting to it because this is a really strong standard for protocols, pipelines, instrumentation, and there's dozens of GitHub repositories under the OpenTelemetry project. And the beauty of all this is that it's a very well-governed open source project. It's part of the CNCF, the Cloud Native Compute Foundation. OpenTelemetry is the #2 project in the CNCF by contributions. The top project is Kubernetes. So that's like the level of governance that we have here. Oh, we just had a governance committee member election last month. There's like committees and working groups and maintainers and approvers. Anyway, it's a well-governed open source project, and you can use it to standardize the telemetry emitted by your application such that you are not tied to any particular vendor. All the major vendors, Datadog and New Relic and Splunk and Honeycomb, receive OTLP to varying degrees of fullness of functionality. But they can all receive the OpenTelemetry standards. And this lets you keep your stuff open source and also not be tied into a vendor. You don't get the lock-in. The OpenTelemetry code provides the scaffolding. It's like, yes, you need to know about network calls and database calls. We know that. And then it adds all the normal fields like HTTP URL, but it's not going to add the headers and it's not going to add the body because those could contain sensitive information. So you need to add the information that's specific to your service, your capabilities. And OpenTelemetry provides an API for that. So it's all like standard and you're not writing code in any particular vendor's language. It's all open source. And there's instrumentation in all the major languages and for all the major web frameworks. This is why it's so big. There are hundreds of people contributing to this because it's got a lot of pieces that all come together to draw that picture for you of what's happening in your software. Right, so you've got the instrumentation, it does the propagation and the HTTP libraries and gRPC and Kafka and whatnot. OTLP is the standard protocol that stands for Open Telemetry Protocol. The L is silent. And then there's a collector, which is you can run it as an agent and like gather metrics, or you can run it to receive and process and send your telemetry on to wherever the heck. Okay, and this results in distributed traces, which are the modern standard for observability. And this results in us being able to answer these questions that we had. And we can run more reliable software at a higher scale with better performance. And most important to me is that we have these pictures of what's going on. And this lets us work skillfully in complexity because we can see the consequences of what we do. And that's the difference. Okay, this is the big difference for me between coding, which is a complicated problem. Our code gets really complicated and sometimes convoluted, although we try to keep that out of it. But in the end, it's always a logic problem, right? We can reason through why a piece of code in a program did what it did based on the input it received and whatever other data it retrieved. And that's complicated, but to do that, to get to that part, you have to get to a piece of code that you understand sufficiently. Observability, like the distributed traces, help us get to that piece of code and then go reason about the problem. But at a higher level, we never understand everything in the entire software system. Nobody understands all of how, no one person understands all of how a ride gets to me. Collectively, a lot of people maybe understand it, or maybe there's some essential piece that the people have left and the software is still running and nobody understands it. And when the software is failing, when there's an incident, then you know it's working in ways you didn't expect, or you would have coded it differently. You didn't code it to do this. And we have to treat the system as complex. And when we work with a complex system, you can't just reason about it. You have to try stuff and see what happens. And we do try stuff. We shut down the pod just before I got on here. I shut down some pods. Kubernetes restarted them and my demo started working again. It's a demo. But we're able to work within complexity because we can see what's happening. We can find out the consequences of what we did because we're never going to be able to predict all of them. We can only predict them within the scope that we can unit test. Right. Yes. So we need to work within complexity like that. And that is a lot of the difference between coding, which is a complicated problem in Kinevin terms, and getting something done, which is always in a complex socio-technical system. We can do some of these things in between. And after our code is released, we can go make graphs of the feature flag and my code being hit. This is if you couldn't query your traces. We query our traces in Honeycomb. And so I can tell when the feature went live and I can tell when people are using it. And then I can like look at the general performance of the system and look for disturbances and see that I didn't make any. And at Honeycomb, we release our software every hour. And when we release it, we release the whole thing, which is questionable, but we do. But first we release it to our internal environment and we go look at how things are working. We turn on the feature flag in a few teams maybe. And then if nothing's wrong, it goes out to production. It goes out to production automatically with some high level checks. And it goes to production and then we go look at it there. Usually things are behind a feature flag, but then we turn the feature flag on and we check the results and we go look at the trace. We look at the trace and see whether our feature is functioning as expected. And then we can look at it again later. And this makes production less scary. This visibility and this habit of going and looking at production, this like accessibility of it's right there. When we're considering things like what we're considering adding a new feature, we're like, maybe we'll add a new way to add alert. Where should we put that? And we can ask, okay, where do people go on this screen? We go query for how many times was this button pushed? We go query for what kind of input data do people use here? And this makes production my friend. And deploys aren't scary anymore because we have this habit of going and looking at what's happening. And that leads us to improvements in things like the DORA metrics. So deployment frequency Lead time for changes. Lead time for changes is like how long between when you commit the code and it gets into production. And change failure rate, how often that failures, or how you want fewer changes to fail. And when something fails, you want to be able to restore service quickly. It turns out that all of these metrics move each other in a positive direction. Now, I think that's because they all come down. Oh, and here they are in the Dora report. They all move each other in a positive direction, so they clump. Teams tend to have all of them looking good or all of them looking bad or somewhere in between. But it's not a trade-off between like deployment frequency and failure rate. You would think that like if we deploy less frequently and more carefully, we would have fewer failures, but quite the opposite is true. The less frequently you deploy, the more likely your deploy is to fail. This is from the State of DevOps report. And the reason for that is I think all of these hinge on the more frequently you deploy, the smaller the change you're deploying. And also time to restore service because you made this change more recently, so you're better able to fix any problems. So all of these lead to and stem from small, fast changes because small, fast changes are safe changes. And that's what we want a lot of. All the features interacting with each other mean the more feature changes you push forward at the same time, the more likely they are to interact with each other, the more likely that is to cause a failure. So when you have something with a nonlinear increase like this, if every feature interacts with each other, then it's like the number of features changes is going to influence the failure rate as like n factorial. It's not really quite that bad, but it is an exponential increase in your failure rate based on the number of changes that you make at once. And when you have a nonlinear increase like that, the way to fix it is to keep it small. Relating to people has this nonlinear increase. It's harder to keep up with more people, and it's an exponential increase. And so we keep our team small. Yeah, so we want to stay down here in the safe part of that curve with small changes. And then we want to go look for consequences and find out. Distributed traces lets us fix failures faster. It lets us see what we're doing. It lets us know where to make the change, know where performance matters. Oh, and here's a favorite bit. This is from the State of DevOps report 2021. Teams with good observability practices spend more time coding. So even though all the things I'm talking about are like outside the code, there's more to delivering or providing useful capabilities than coding. We love coding, most of us. And so we do get to spend more time on that when we're able to fix failures faster and troubleshoot more quickly. All right. So observability has a lot of places on the road to getting something done. I use it at the very beginning when I'm finding out where should I make a change. And then I use it locally, personally. I look at traces during testing. And then absolutely once I get into any sort of shared environment, integration tests, distributed traces are incredible because they tell you where the failure is. And then you can add attributes for the input that you think someone is sending you wrong. And you can say, no, look, you sent it in all caps and we wanted it in all lowercase. And, I'm just going to change my code to be case insensitive kind of thing. And then when things surprise you in production, you have the ability to resolve it much more quickly, which makes deploys less scary, which lets you do more frequent deploys, which makes them fail less, which means you spend more time coding. And more importantly, you get more things done. And not only do you get things done, but you have visibility into the importance of those things. So when you do more than change code, when you're thinking about the system as a whole, and when you can see what impact you're having on your customers, because you can see how much faster it is, you can see how much it's costing you on AWS, and you can see how many people are using your feature and whether they're using it like you expected, then we don't get the satisfaction of, oh, my code is shipped, it's done. But we do get the satisfaction of knowing that the code we wrote is useful and that we continue to take care of it and grow it. And so our software is more like a team member and not some widget we kick down the road. I want to end with this quote from our CTO, Charity. As an individual, I can write software, but it takes a team. It takes more than one person, and it takes production to deliver, ship, maintain, and own it, to provide valued capabilities. That's why we need a team, and we need the software to be on our team. There it is, the learning team with people and code. And that's what I have. I'm good, and we have a good 15 minutes for questions because I have a feeling y'all will have some interesting ones. Here's a URL with some links and like my contact info.
Go ahead, Narendra. So I'll be helping with the questions. Go ahead, Narendra.
Yeah. First of all, hey, great talk, Jessica. So I was just wondering, so we have the basics of observability built in, but currently it's kind of a reactive process. When something goes wrong, that's when you start adding the things. But I think from the principle of shifting left as much as we can, what are your thoughts about the tips we can make observability a part of the development as opposed to just leaving it as a tech debt to be worked upon later?
Ah, what a wonderful question. I love that question because as a developer, I really love to build an observability. So one strategy that I have is, you know how you're developing along and you'll add like a log statement or I'll add console.log, Jess was here if I'm in Node. I mean, there's a point where I really just want to say Jess was here, and no, that doesn't need to be in production. But I shift pretty quickly to wanting my traces to tell me what's happening. So I send traces locally. I send them to Honeycomb because like a free Honeycomb account is plenty, and that's easier. But you can also stand up Jaeger locally. So I pretty quickly move into seeing a difference in my traces. And actually even before that, when I'm about to make a change in the software, I ask, how will I know this is working in production, not just in tests? So this, Sapan mentioned outside in testing, we don't do a lot of that at Honeycomb, but we absolutely do it in the sense of we test in production, not only in production. But I look at a trace and I say, where will my change show up? How will I know it's working from the trace? And often that means just adding an attribute somewhere. Sometimes it means creating a new span if I'm doing something really interesting. And then I code that in to begin with. So instead of like test first, it's like trace first in that sense. I know where I'm going to see the change. And then I make sure that shows up in my development cycle. Some people actually write tests to verify that the attribute was added to the trace. I don't go that far. That feels brittle to me. But I absolutely want to see it in the trace in my local. And then when it fails an integration test, I know exactly where to look.
So, and Jessica, that's exactly what I wanted to ask you right now. That so when you are writing code, you have like traces also. The way we treat observability and telemetry is, hey, you look at it after something is deployed.
Mm-hmm.
We rarely like see any kind of observability when we are developing. So you're saying that you actually trace everything that's going on in your local desktop as well and seeing the traces, like as if we were looking at them in developer tools like console.log, Jess was here.
For a lot of changes, yes. I mean, there are some things, okay, UI changes, not so much. But if it's in the back end and it's like a log, every time I have an if statement, I want the variables in that conditional on my span. because that's affecting the logic of the program, and I want to be able to tell which path it took. Sometimes I won't put the whole, all the variables in there. I'll just make sure I know which path it took by adding a field of effectively just was here, except with better naming. Chose this path. Now, I should be careful and warn you that it depends on your telemetry backend sometimes. Something like Jaeger or Honeycomb does not care how many attributes you have on your trace. Something like Datadog, I don't know for sure. I'm not an expert in Datadog, but they might charge you per attribute. So you do need to be like aware of where you're storing these things. But then you get into some people filter those out in the collector so that they have them sometimes and not others. And then there's sampling to reduce the cost of tracing, which is its own topic.
And Jessica, one follow-up question on this one. As we were talking about batching, and we were talking about DORA metrics, and it seems that I think at least some of us, when we work, we have a very heavy distinction of when we are developing something and when it goes in the deployment, right? So it's like before production and after production, sort of like two different worlds. That
Oh yeah, do you have different
in.
people responsible for it?
No, it's the same team, but it's
Okay,
once it goes in production, we are a services company, so it's literally clients' production. So we sort of lose control once it is in production. CI/CD pipeline will run, and it will go on the servers, which we don't have access to. We don't have access even sometimes to the observability dashboards. Only a few of us
if
has
you don't
it.
have access to observability in production, how the F are you supposed to support your own code? That
becomes a problem.
Cultural
That does become a problem.
Yeah, you absolutely need access to the dashboards and the more detailed traces. In fact, like ops people who are focused on software as a whole can work from dashboards because they don't know the details of the software. They have to treat apps as like generically apps, like pods and Kubernetes. Not working, kill it. And that's like the limit of their interference. But as the developers, we need more detail. We need to be able to query by our attributes and stuff like that. So this is how observability is different from monitoring. Observability in its modern form of distributed tracing mainly is for the software that you have under development. It's for your software that you control and that is like your business value, right? This is your company's secret sauce of what makes it valuable to customers. That's where you need observability. If people are just like operating Kafka, whatever, monitoring and occasionally logs are fine. Keep your software that you are investing millions and millions and millions of dollars in every year. There, you need great observability, and your devs need access to it.
Got it. But still, I think, Jessica, I had a different question. I was just trying to make this distinction of things before deployment and after deployment. And the reason I say this is that there's some practices, right? We'll do TDD, pairing, or even CI/CD. All of that is just before something gets deployed.
Right, we tend to talk about those a lot more.
Right, yeah. And then there's observability monitoring that's after it's deployed on some environment, and that's when you see it. While we talked about a lot of things, you said that, hey, it increases your confidence in deployment, and you gave a lot of credit to observability. So I wanted to hear, if you wanted to, like, if your confidence is 100%, how does it break it? Like, what's the part that TDD plays, or what's the part that CI/CD plays? What's the part that observability plays?
Yeah. And I'm not talking a lot about CI/CD and TDD because there's a zillion other people talking about that. And because it's not a change, right? CI/CD and automated testing, not necessarily TDD. Not everybody does TDD, but everybody does some automated testing. These are table stakes. Observability right now is like a competitive factor, and soon it'll be table stakes too.
Got it. Got it.
Yeah, but absolutely, we have automated testing for the stuff that we can unit test. There are some things like lambdas, our serverless functions, which we run millions of, and well, millions of the same one, and is an integral part of our database. We really can't test that locally. It's not meaningful. We do deploy to our internal environment called dog food, which is the instance of Honeycomb that we use to observe production Honeycomb. And so we check it there. And then if it's not working, we push a button. And the only thing we have for like automated end-to-end kind of tests is we have an automated check on our service level objectives in dog food. So things run in dog food for half an hour or so before they get shipped to production automatically. And we have a check that if any of our service level objectives start plummeting and are in danger of exhaustion, then we hold off. So we do have like very high level checks there.
Awesome. Just to summarize what you also said is that, hey, everyone's not only observability is in addition to TDD, CI/CD, and all of our automated testing and all of it. And of course,
yes,
there's a lot of talk happening about TDD or many of these other things, but observability still kind of needs to rise a little bit more and does the talk or does more focus on it. I want to move quickly on. Nitin asked this question, and I think this is in response to when we were talking about, hey, not all our customers may give access to the portals, observability portals. Nitin asked, does this logging involve sensitive data, and does it have any overhead of security? And I think the reason he asks is that most people actually, okay, you answered it, it seems. Most people actually do not give access, saying, hey, it may have sensitive data. So we are not, usually fintech, health tech just has a policy that nobody gets to see the data of
right. And
tools
it depends.
Like
it depends. Like, yeah, if you're in health, you don't want any identifying data in there. If you're a B2B SaaS company like us and there are Honeycomb login infos in there, whatever. It's where you have your security. So we have security around getting to our data. We would never log a credit card number, or a password, we do not put that in our trace data. The best practice is to put in a primary key for the row, but that primary key itself is opaque. You have to separately have database access to get any information out of that. That's really good for customer service. Customer service, at least at Honeycomb, and a lot of our customers, customer service accesses the observability data to look at traces and find out what happened when someone's complaining that their request didn't work, or they're getting a lot of errors or something like that. And one of the benefits of putting a user ID, even if it's obfuscated, putting a user ID on your traces is when there's a failure, when we're getting like an 80% error rate instead of 0.1, who is it happening to? You can find out whether maybe it's only an 8% error rate, but is it 8% and it's all your biggest customer? Or is it 8% and it's only free accounts? Different urgency level there.
Makes sense. I wonder if we have any more questions. I think, is there a difference? While you were talking, just again, there's no more questions. I can use the last 2 minutes as well. Maybe a very basic sort of a question. Is there a difference between just log aggregators? Where do log aggregators sit, like ELK, let's say, or even nowadays, Azure not what is it called? Azure App Insight would show you logs as well. Just regular logs. System.out.println will also show up.
Yeah.
So
Yes.
usually
So logs
they're on the same.
logs versus traces. The benefit of logs is you already have them. And on systems that you don't write and you don't get to control their add instrumentation and control the telemetry, you're stuck with logs. What traces add is a connection between them. You can get some of this from if you like emit a request ID in all of your logs and you propagate that request ID down, then you can sort things by request ID and then timestamp. But then you're just hoping that like the time order is also the causal order. Whereas in traces, it tells you the causal order. For performance, logs are such a pain because you've got the start log and you've got the end log and you've got to correlate those into a calculation. And with a lot of pain, you can do that in Splunk and it will be slow as heck. If you have traces, it's right freaking there. Concurrency problems are wicked to debug in logs. Good luck. Just no. But in traces, they're right there in front of you. Even I had a tiny simple node program the other day and I looked at a trace and went, oh crap, that's a concurrency error. Because it shows you what's happening at the same time and what waited for what. You can see like the spans are separate if this happened synchronously and in the order I wanted. So that's another one. Oh, and then when you get to cost, okay, if you want logs, you pretty much have to save them all. And so things like ELK, and eventually everything winds up in S3, but there's a big focus on volume. Traces, you're going to have volume, yes, but you can control that volume by sampling, by saving. You want to save like every trace that failed and every trace that was exceedingly slow. But of the others, maybe save 1 in 20. And you can do that and filter it, and the data is still meaningful because you're doing it at the level of a trace of an entire story instead of like random statements. So your cost considerations are different, and that way you can make your traces way more queryable and put them in more expensive storage and get more access and get more value out of them than logs, which are a big pile of text.
Actually, and thanks a lot for bringing that up, Jessica, because this has happened so many times to us. And I don't know if you know, like right after how the economical environment started, taking a dive, I think the first thing that people looked at was cost for logs. And so everyone that we were working with, previous employers, all of them were just looking at these logs. And there were these places where just what you mentioned, right? Jessica was here, sort of a log statement, being there a couple of millions of times a day and costing the company a fortune. And really, all the exercise people had to do was delete these log statements, push it, and save ourselves a couple of hundreds of thousands of dollars a month. So, or exceptions. I remember someone doing, how the Java has a full exception trace. And there's actually, I don't know if you know it or not, I came to know just last year that there is, like there's some setting, environment variable or Java flag, that can limit the number of lines to, let's say, 3 lines or 4 lines and not an like entire, and just change that and save yourselves hundreds of thousands of dollars. So sorry, but yeah, taking the conversation over, but it makes a lot of sense that logs are just staying there. People are not using it until you start looking at the cost and thinking that, hey, this is totally useless, let's just delete like a bunch of them.
Yeah. There's a question in the chat about correlation with different events that might be happening down the line, like a GC pause or maintenance downtime, CPU utilization. Do you have any tips about how should that problem be tackled? So like CPU utilization, you can't attribute that to a particular request. That is one that's like, it's kind of like the environment, right? I think of it like the weather. You need to know like if you're evaluating someone's driving, it's relevant whether it was raining, whether the roads were wet, what the temperature was. But you can't blame them for that. Metrics are for the weather. You want metrics around CPU utilization because that's going to impact the performance of your code. And when a GC pause happens, it's going to impact the performance of your code. But it can't be blamed on that particular place in your code. So you want to keep some metrics and be able to correlate those to your traces. And that correlation is time and machine based. So that's what we do at Honeycomb. Like we get all the Kubernetes metrics, which tells us pod, CPU, and memory utilization. And we make sure we can see those on the screen along with the queries over our traces. So we can see, okay, how slow are things? And in which pod are they slow? And what's the CPU utilization kind of thing? For things like optimizing memory and CPU, we'll use a trace to be like, okay, this is the slow thing that we want to make better, or this is the thing that's happening the most times is another thing we can get from querying our traces. And then we'll drop down to our profiler. So in that case, observability is higher level than profiling, but it can help you get to the right spot. And then measure your results because you can see, is this happening fewer times or is it faster?
We're 5 minutes over time. I wonder if there are more questions.
I want to thank everybody who had their cameras on. It's really good to see people.
Thank you, Jessica. Well, awesome. Thank you so much, Jessica. Thanks for joining us. There will be a YouTube video which will be recorded and uploaded. And I think there's no other questions, but if there are any other questions, please feel free to send them in chat and maybe we'll pass it on to Jessica if she gets time to respond back to them. Thank you so much, Jessica.
Okay. And I put the URL in the chat for resources and contact me.
Perfect. Thank you.
Thank you. Great to talk to you.
Thank you so much.
Bye.